We are going to discuss integration. Is from Maths 1 of A levels, pure Maths 1 from Cambridge International, and it's exercise 9C, question number 3. So, question given is a curve is such that its gradient dy by dx is given as k times x minus 5 raised to power 3. So this is the gradient given k is some constant. This is some constant term. We don't know about it. We have to figure it out. What is the value of k? The gradient of the normal to the curve at the point. So usually, like if you have got some curve like that, so the gradient is measured at any given point, if line that is just touching to it, right? So this is gradient of the curve at this particular point P. And when we talk about normal, so normal is something which is crossing gradient at 90 degree. So we are given the slope of this normal curve, normal, and this is called tangent to the curve. So gradient of curve at any point is the gradient of the tangent. So we are given gradient of the normal curve. So gradient of normal, let's call it m dash. So this is gradient slope of normal, gradient of normal. So this is equal to 1 over 12. And whenever we are going to have a curve, so it's important to know at which point we are going to have this gradient. So point is given at point P, its coordinates are 4 and 12. 4 and 2, sorry. 4 and 2. So what we have to find? We have to find equation of the curve. Equation of curve. So we have to find what is y of y. So first of all, we start from our gradient thing. So we could find out what's the value of k. So to find the value of k, let's see the gradient. What is the value of gradient dy by dx? So if the gradient of normal is 1 over 12, so always remember relationship between the gradients. So if m is gradient of the curve and m dash is gradient of the normal, their product is equal to -1. Gradient of perpendicular lines is their product is equal to -1. Or in other words, we can say like m is equal to negative reciprocal of normal, gradient of normal. So over here, minus 1 over 1 over 12. So this become equal to -12. So gradient of the curve, which is dy by dx. So m is equal to dy by dx at our given point is equal to 12. So this is k x minus 5 q at point 42. So this is equal to -12. So we know the value of x. X is equal to 4. It is given over here. So we plug in the value of x over here. So we get k 4 minus 5q is equal to -12. 4 minus 5 is -1. -1 cube is -1. So let's call it like minus k. This is equal to -12. So we get value of k equal to 12. We have found value of 12. So now we got expression for dy by dx, and then we have to solve for y. So dy by dx is equal to 12 x minus 5 raised to power 3. And we have to integrate it. So we integrated dy by dx dx. So this is 12 x minus 5 cube dx. 12 is constant, so it's outside. And then x minus 5 cube, simple power rule. So x minus 5 raised to power 4 divided by 4. For integration in power rule, we increase the power by 1 and divide it by this power. Don't forget plus c, constant term. So we can cancel 4 and 12, so we get 3 over here. So we got this expression for integration 3x minus 5 raised to power 4 plus c. This is equation for y. We need to find out the value of c. So we have got the point 42. So p 42. So we plug in the value of x and y over here to find the value of c. So y is 2 and x is 4. 4 minus 5 raised to power 4 plus c. That's easy to solve. So this is 2 and 3 times 4 minus 5 is minus 1 raised to power 4. Negative number raised to power even, so it's will cancel out, drop out the negative sign. Negative into negative, positive, that's why. So we get 2 is equal to 3 plus c. Bring 3 on the other side, c is 2 minus 3 is equal to minus 1. So we have got value for constant c. So final expression for our equation is y is equal to 3 x minus 5 raised to power 4 minus 1. So over here we did a simple integration in which we have to find equation of the curve. We have to solve integration by power rule and find out the value of different constants. Constant given in the question and then constant of integration. So let's move on to next question. I erase all this stuff and I write down the next question. So this next question is from exercise 9E. This is about definite integration. Exercise 9E, and it's problem 2, part F. So over here we have simply have to use definite integration. So I write down the equation given in the book, in the problem. So we have to integrate from point 1 to 4, and the given expression is 3 under root x plus 2 over under root x dx. So we have to do simple integration of power rule, and then we have to plug in the limits 1 and 4. So if we are integrating it, so separate integral over two expressions. So this become 1 to 4, take constant out 3, and integration of under root x dx, plus again take constant value to separate, and inside is 1 over under root x dx. Integration is from 1 to 4. When we are doing definite integration, so we don't care about the constant, because eventually when we are going to minus one term from the other, upper limit from the lower limit, constant is eventually going to cancel out. So we can simply ignore the constant. Let's solve it. So we have got square root of x. Let me write it down in its power. So square root is power half, 1 by 2. So then we can apply our power rule more easy. So 1 over under root x. So it's like 1 over x raised to power half. So it's better I just put it up. So it's going to be x raised to power minus half dx. Now we apply power rule of integration. We get 3. Will put limits 1, 4 at the end. So x raised to power half. This is x raised to power 3 by 2 divided by 3 by 2 plus 2 x minus half. So we increase it by 1. So minus half plus 1, we get 1 by 2 divided by 1 by 2. And over here, I just express my limits, not to forget, like we are still considering the limits. Actually, plus c plus we ignore because of these limits. So we plug in the values before plug in the limits. So let's simplify this expression. So 3 is cancelled with 3 and divided by 2 go up here. So this is 2 x raised to power 3 by 2 and plus 2, and this is my 1 by 2. 1 by 2 goes up, so this become 2. So 2 into 2, 4. 2 divided by half is 4 eventually. So 4 times x 1 by 2. And we have to put limit on all of this expression 4 to 1. So let's solve this definite integration, plugging in the limits, upper limit minus lower limit. So we plug in upper limit value, which is 4 over here, minus lower limit, which is 1 over here. So let's solve for it. So I just put equal sign here. So 2 and solve for the first one, x3 by 2. So this is 4 raised to power 3 by 2 minus 1 raised to power 3 by 2. That's good. And then plus, I put 4 here. X is 4 raised to power 1 by 2 minus 1 raised to power 1 by 2. 1 raised for anything is 1, so that simplify our life, make it easy. So 2, 4 raised for 3 by 2. So 1 over 2, so 4 raised by 1 over 2 is square root, so that is 2. So 4 raised to power 1 by 2 is 2, and then we make it power 3. So 4 1 by 2 raised to power 3 is 2 raised to power 3 is equal to 8, right? So I put 8 over here for 4 raised to power 3 by 2 is 8. Minus 1, minus 1. 1 is by anything is 1. Plus 4 times 4 under root is 2, and 2 minus 1. So let's do 2 for 8 minus 1 is 7 plus 4 into 1. We get 14 plus 4 equals to 18. This one. So this is definite integration of this this expression. We integrated it. I just want to tell one more thing. We have got the answer, but how to interpret this result? Actually, whatever this curve is going to be something, let's suppose like this. It's not going to, it's not like exact curve, but suppose it is like this. So our limit is when x is equal to 1 till 4. So let me draw this line, 1 to 4. Definite integration tells how much area is under this curve from the limit 1 to 4. So this is an important thing to remember. Integration gives us area under an equation, area under the curve of an equation. And when we put the definite integration, so that is like area under the curve from starting point till the end point. So over here for this curve, area under the curve from point 1 to 4 is equal to 18. So that was one small exercise on integration and definite integration.